Welcome. This is section 13.2. In this section, this is about applications in business and economics. In this section, we will be talking about various topics, but some of them are going to be your continuous income stream, which we will be talking about. We're going to be talking about the future value of continuous income stream. We will talk about consumer surplus and producer's surplus. I'm going to give you examples, so we're going to do it step by step. I'm not going to go over and read this one. These are your formulas. Again, before we start this section, I want you all to go ahead, read your glance or read your PowerPoints, your textbook, very, very, very important, and then use this as a resource to go ahead and finish your homework. So let's get started with the first problem here. It says find the total income produced by a continuous income stream in the first 15 years if the rate of flow is given by the following function where t is time in years. So given a problem like this, because they have mentioned it's a continuous income stream, I will go back to my reference here and see a total income for a continuous stream, which is this, if f of t is a rate of flow for a continuous income stream, then the total income from time a to b is integral a to b f of t dt. So this is what you need to have on your notepad or your note card when you're taking the test. Again, integral is the cumulative value of the area under the curve. So here they're asking me for total income produced. So to do that, I will go ahead. Do I have my function? Yes, I do, with the following function. The rate of flow is given by this function. So all I have to do is integral a to b. You know what? Let me write this here. It's going to be integral a to b f of t dt. Now, what is my f of t? My f of t here is 2,500. So it's going to be integral a to b 2,500 dt. But you might ask, Miss, what is a and what is b? How do I know? They did not tell me. They said the first 15 years. That means you start from your 0, go all the way up to your 15. So this is your a value is going to be 0 and your b value is going to be 15, and this is 2,500 dt. Finding the integral, it is going to be 0 to 15. Integral of 2,500 is 2,500 t. And again, once I have this, I will plug in my upper value and subtract from the lower one. Because the lower one is a 0, I don't have to put that. This is simply going to be 2,500 times 15, which is going to be, let me plug this in, 37512. So 37,500 is going to be your answer. So how much do you earn over 15 years? $37,500. And again, how did I know all of this? Because it clearly says it's continuous income stream. All right, now let's take a look at the next one. Starting at age 35. So let me pause here. We're talking about the IRA accounts, which is very, very important. And again, if you all have not started, if you did not start your IRA account, I would highly recommend y'all to go ahead and do that at a young age, because trust me, it is going to be very useful when you retire. Now, let me quickly talk about what IRA is. IRA is your individual retirement account. The earlier you start, the more money you save. So let's go ahead and take a look here. Again, if you have not looked into it, please go ahead and do so. At age 35, you deposit $2,000 a year. So you're depositing $2,000 a whole year. That could be probably $100 a month or $200 a month. You can distribute that $2,000 however you want. But in this case, because it's IRA, you have to put a regular amount into your account. So you're depositing $2,000 a year into your IRA account for retirement. treat the yearly deposits into the account as a continuous income stream. So they said you're depositing yearly $2,000. Now you can save $100 a month, $500, and then accumulate that into 2,000 and then deposit that. So very, very important. Again, I can't insist how important it is for you all to look at IRA if you're just starting your career, because this will help you down the road. So now they're asking us to treat the IRA as continuous income stream. If the money in the account earns 6% compounded continuously, how much will be in the account 30 years later when you retire at the age 65? So this is the best example. How much of the final amount is interest? So you are putting $2,000 every year. How do you save this? You save $100 a month, $200 a month, or $500 a month. So accumulate 2,000. That doesn't matter. But every year you're putting $2,000 into your bank account, and you do that for about 30 years. And at 65, how much money will you have? Let's go ahead and take a look. It's continuous income stream. So here we are talking about what is not the total. We're talking about what is going to be your future value. So f of t, if f of t is the rate of flow of continuous stream, if the income is continuously invested and it's compounded continuously, then the future value is this. I would like to go ahead and use this one, the final one, because again from here you will get to this one. So go ahead and use the second part of it, which is much more simpler. So first let me go ahead and write that formula. So the formula I will be using here is future value, because it is continuous income stream and they mentioned it's compounded continuously. It is, oops, I missed, e to the power r t integral 0 to t f of t e to the power negative rt dt. We're going to talk about each of this separately. Now E is E, R is, let's go back here, R is the rate which is compounded 6%. So in this case your R is 0.06. And here the time is 30 years. So your capital T is going to be 30 years. And what else do you need? Your FT, your function, your starting your initial value here is $2,000. So you're investing $2,000. This has been compounded continuously. You're trying to see what's going to happen. What's the future value after 30 years? That's exactly what you're doing. Again, you will go ahead and use your integral. Let's plug all of this in here. So this is e to the power r is 0.06 times, I'm going to put parentheses. It makes my life so much easier. 0 to 30. F of t is 2,000. E to the power negative 0.06 times t dt. All right. Now what I'm going to do is, because this 2,000 is a constant, I'm going to pull that out. So this is going to be 2,000. Let me go ahead and see what this is. I think this is e to the power 1.8 integral 0 to 30 e to the power negative 0.06 t dt. Now let me quickly give you a formula here. Integral e to the power ax dx is simply 1 over a e to the power ax plus c. Make sure you write this down somewhere so you know what this is, and every time you see e to the power, you'll simply go ahead and use that formula. So using that formula, I will have 2,000 e to the power 1.8. Let me move this down just a little bit. Integral 0 to 30. This is e to the power negative integral of e to the power ax is e to the power ax divided by A, which is negative 0.06. And now all I have to do is plug in my 0 and plug in my 30. I don't have to plug, yeah, I think I have to. So let's go ahead and see this. This is 2000 e to the power 1.8. What I'm going to do is I'm going to bring this out because that's a constant. In here, I'm going to plug e to the power negative 0.06 times 30 minus e to the power negative 0.06 times 0. Now go ahead, put this whole thing in the calculator. Make sure you have parentheses for this one and this one and this one as well. And once you do all of that, I don't know what I get. Let me go ahead and plug this in. I end up with 168.3. I think they're asking us to round off to the nearest dollar, and that's what I end up with. $168,322. Okay, so you're investing $2,000 a month, $2,000 a year up to 30 years, and this is what you have. And now, what are they asking me? That is the value of the IRA when you turn 65. So how much of the future value is interest? What is that? So this is what you'll have in your hand when you're at age 65. But let's do the math here. They're asking you for the interest. So what's the profit? What's the interest that they paid you? Remember, you are paying $2,000 a month for 30 years. That means you only paid $60,000. So here, 168,322 minus 60,000 will give you 108,322. So whatever extra, this amount extra is your interest. Remember, you only paid 60,000, but you got 168. That means this is the interest that IRA paid you over 30 years. So now you see why I ask you to invest in IRA. Very important and very beneficial, especially if you start very young. I did not do that. I did not use my IRA when I was young, so I don't want y'all to do the same mistake. All right, now let's go ahead and take a look at the next problem. Let's see what this says. Again, for this problem, please take your time, go reverse, forward, slow, but make sure you have this formula. It makes your life so much more easy. And all I have to do is divide by 0.06 here. So make sure you have that formula and work this out, okay? All right, now for the next one. The rate of flow, ft, for a continuous stream is a linear function increasing from 3,000 per year when t is equal to 0 to 5,000 per year when t is equal to 5. Find the total income produced in the first 5 years. So now they clearly mentioned this is a linear function. So that means this is y is equal to mx plus b. And this is a continuous income stream. That means I have to find the integral. But where is my function to start with, right? I don't have a function. So what I'm going to do is I'm going to use these 3,000 per year when t is equal to 0 and 5,000 per year when t is equal to 5 as my coordinate points, and then find the equation. Let me show you how. So it is 3, is that what it is? Yeah. It's when t is 0, it's 3,000. You might say, Miss, why you took 0 as x? Time is independent, so you always take time as your x value, and your dollars depend on the time, so that is going to be your y value. So this is my x1, y1, x2, y2. So the first thing to find the equation of a line is to find your slope. Your slope is y2 minus y1, which is 5,000 minus 3,000 divided by 5 minus 0, which is 2,000 divided by 5, which is 400. And that's your slope. Okay, once I have my slope, my next step is to go ahead and let's see what I'm doing here. Once I have my slope, y is equal to 500t plus b. Where's my b? Remember, when x is 0, that means the rest is your y-intercept. So I have y is equal to 5. Now, why am I putting y? Your function has to be f of t. F of t is 500t plus 3000, which is your y-intercept. How do I know this is my y-intercept? Because my x value is a 0. And now once you have the function, you know that the total income is going to be from 0 integral a to b f of t. That's going to be your total income, right? So this is, now what is your a, what is your b? Where do you start? You start when t is 0 and you end when t is 5. So this is going to be 0 to 5. Your f of t is 500t plus 3000 whole thing dt. And that is going to, where did I get 500 from? This is 400. 444. So where did I get the 5? 400, 400, 400. Sorry about that. So this is integral 0 to 5. Integral of 400 is 400 t squared over 2 plus 3000 t. And when I simplify this, this is going to be 200 t squared plus 3000 t. So what I'm going to do is go ahead. I don't have to plug in my 0 because when I plug in a 0, I get the whole thing as a 0. So I'm going to go ahead and plug in my 5. 200 times t squared. 5 squared is 25 plus 3000 times 5. And let me go ahead and plug that into my calculator. And that is going to be 20,000. Quick recap. What did we do? They said it's a linear function, but they did not give us what the function is, but they give us the points. So we go ahead, find the slope because that's required for a linear equation. Once I have my slope, I have my y-intercept, I have my whole function, and I integrate it from 0 to 5, and I get my total value. Fair enough. Now let's go ahead and take a look at the next problem. Here it says find consumer surplus at price level of P is equal to 100 for the price demand equation below. Now, before I go ahead and talk to you about what is this, just go ahead and do the problem. It's very important. I want to talk to you about what exactly is this consumer surplus. Now, let's go ahead and think about the time when we were running short of toilet papers, right? So what happened during that time? The toilet papers were in high demand and the price went up from, let's say, $3 to all the way to $5. Now, as a consumer, even though you know the price is at $5, but you still had a chance to buy the toilet paper at $3, then you saved that $2, right? Then you saved $2. So this saving of money when a consumer can or could have bought the product at a higher price, but still bought it at the regular price, that's called consumer surplus. And again, this is simply, it just represents the saving to a customer who is willing to pay more than the regular price, but was still able to buy it at the regular price. Okay, the saving that you saved is your consumer surplus. Now let's go back to the first page here, consumer surplus. This is if XP is a point on the graph of the price demand equation dx for a particular product, then the consumer surplus CS at the price level of P is, this is your equation. Now, you might say, Miss, what exactly does all of that mean? Not to worry here. I'm going to go ahead and do each one of them so you can see exactly what I am talking about. So let's go ahead and take a look at this problem. Just let me go back to the problem here. And again, we'll start from the beginning. So it's a consumer surplus is given by, I'm just going to write consumer surplus at CS. That is given by integral 0 to x bar dx minus p bar and the whole thing dx. Now, this is the formula. Very good. Let's go back here. And if I look, I have my dx and I have my p bar, but I don't have the x bar. Now to do that, I have to know what each of them is. The consumer surplus is given by this integral here, where p is your current price and x is the quantity demanded, and this x bar is the current demand of your product. So this is your current demand and this is your current price. You're subtracting that from your price demand equation, and the difference you get is your consumer surplus, because that's the amount you saved. Now, how do I do this? Where do I get all this information from? Again, it's very important you understand each and every term here. So this x bar is nothing but your current demand, and this is the p is your current price. And this dx is, it's the price demand equation. Now, let me go ahead and let me plug that in here. Again, I want you to be very patient here. This is 0 to x bar. I'm going to do all of that. My dx is 200 minus 0.02x minus my p bar is 110. Again, when I integrate it, 0 to x bar, 200 minus 110 is 90 minus 0.02x. Now, I cannot complete without knowing what's my current demand. But where do I start from? I know dx, which is the price demand equation, is 200 minus 0.02x. Now I'm going to use this and equate this to the current price. What's the current price? 110. So when I equate these two, I will get the current demand. So when I equate the demand equation, remember this equation, this equation will, the price demand equation will give me the current price. So when I equate both of them, I can find the value of x. So when I subtract negative 0.02x is equal to negative 90. X is equal to negative 90 divided by 0.02. This is 4,500. And once I have that, I will go ahead 0 to 4,000. So the current demand is 4,500. That means right now the price $110 is for the current demand 4,500. So let's go ahead and plug 90 minus 0.02x. Did I forget the dx? Yes, I did. And now when I integrate it, 0.4500, derivative of 90 is 90x minus 0.02 x squared over 2. And again, I don't have to plug in the 0 because I will end up with a 0. So what do? I will simply go ahead and plug in my 4,500. And once I do that, I get 90 times 4,500 minus 0.02, 4,500 squared divided by 2. Plug it into the calculator. I get 202,500. Now you might say, Miss, what is this? What is 202,500? This is the amount that the consumer saves instead of buying at a higher price. The price, depending on the demand, the price is going to be higher, but this $2,202 is what the consumer would have saved instead of buying at a higher price. Okay? Now again, please make sure you read what consumer surplus is, producer surplus is, and what equilibrium is. And once we know all of that, it makes so much more easier. But it's very important you understand what D of X is, the demand equation. P, current price, X bar, current demand. How do I find X bar? Equating both of these, and once I know the current demand is 4,500, that means the demand went from 0 to 4,500. As a clever consumer, if I buy it at the price, I will save 200,000 202,500. So I'm going to save $2,500. Okay, there you go. All right, now let's go ahead and take a look at the next problem. Here we have find consumer surplus and producer surplus at equilibrium level. Now you might ask, Miss, what's a producer surplus? Let's talk about recent the egg demand. Right? The eggs were in so demand. You go to Costco, you go to Kroger, they put a limit on the amount of eggs you can buy. And what did they do? They increased the price of the eggs. So even though they bought the eggs for the regular price, because of the demand, they increased the price of the eggs. And the amount of money that they made from the increase is the producer's surplus. So what we save is consumer surplus. What they gain is producer's surplus. Okay, isn't that funny? And the equilibrium is when the producer's surplus, where the demand is same as the consumer's surplus. So let's go ahead and take a look at this problem here. Let me move this one. Let's see. So the first step in finding the equilibrium price is at which the quantity supplied is equal to the quantity demanded. So the consumer surplus should be equal to the producer surplus. That means there's the same demand for the same quantity that has been supplied. So to do all of that, my first step would be to equate both the functions. Equate P of S is equal to C of S. Now let's take a look here. My P of S is D of X. My D of X, which is the consumer surplus. My S of X, which is a producer surplus. 39, let me write these down here. My D of X is 39 minus 0.08x. Is that right? Yes. My S of X, which is the producer surplus, is 13 plus 0.05x. Now what you can do is you can graph both of these and then find the point of intersection. You can do that, but I'm just going to do it manually here. So I have 39 minus 0.08x is equal to 13 plus 0.05x. So I subtract 13 from both sides and add 0.08x on both sides. And what do I have? This I have 26 is equal to 0.13x. And I divide both sides with 0.13, so I get my x is equal to 200. And as you can see, once I have my x as 200, I'm going to go ahead and plug that into the equation. So I can take this 200 and plug it into this one, or I can take it and plug it into this one, so I can get my equilibrium price. Because remember, the equilibrium price is when the consumer surplus is same as the demand producer surplus. So I'm going to take this x And I have, so my supply demand is 200 units. So 39 minus 0.08 times 200. Let me plug that into the calculator. And I end up with 23. So my equilibrium is when X is at 200. That means the demand is at 200, the supply is also at 200, and the price is $23. Now they're asking me, how do I find the consumer? They ask me to go ahead and find the consumer surplus, which is CS. And remember, the formula is 0 to 200 because the demand is 200. Let me use a different color so it's easy for you to see. Let me use this one. It's 0 to 200, and the formula was dx minus p. So my dx here is 0 to 200, 39 minus 0.08x. What's the price? The price was $23 minus 23, whole thing dx. So this is 20. So all I have to do is simply go ahead and let me see what I get. This is integral 0 to 200, 16 minus 0.08x. And once I find the integral, what do I have? 0 to 200. This is 16x minus 0.08 x squared over 2. I don't have to plug in my 0 because I know I'm going to get everything as a 0. So I'll simply plug in my 200. 16 times 200 minus 0.04 times 200 squared. Let me plug that into the calculator. And I end up with 1600. If you can see that, that's going to be $1,600. So as a consumer, when the demand is for 200, then I save $1,600 as a consumer surplus. So that's CS. Let me rewrite this one. That's my C and S. Now they're asking me to find even the producer's surplus. Let's see, do I have another page? Yeah. Oh, no. Yeah, I'm going to find my producer's surplus right here. Now they're asking me to find the producer's surplus. Again, you have your formula in your textbook. The formula for producer's surplus is going to be P minus S of X dx. So let's go back here. A producer's surplus is going to be integral 0. Again, it's all the way up to 200. That's what the demand is. 200 P minus S of X, which is integral 0 to 200, 23 minus, what was my S of X? Yeah, minus 13 plus 0.05x dx. Again, when I simplify this, this is 0 to 23, 10 minus 0.05x dx, integral 0 to 23, 10x minus 0.05 x squared over 2. I don't have to plug in my 0. I'm going to plug in my 23. Oh, did I put 23 here? This is 200. I don't know where I got my 23 from. 200, sorry, 200. I have my kids knocking on the door, so probably I got distracted. 0.05, 200 squared over 2. Again, this is, remember, it's from 0 to x bar, which is your current demand, and your current demand is 200, and you found that by equating your consumer surplus and your producer surplus. Don't forget that. And when I plug this into the calculator, I end up with 1,000. So my consumer surplus is 1,600 and my producer surplus is 1,000. Now let's take a look at the graphs. Let me show you the most easiest way to think about the graphs. My dx was 39 minus 0.08x. My sx is, what was that? Yeah, 13 plus 0.05x. Now look at this. One has a negative slope, so the dx is decreasing. The other one has a positive slope, so it's increasing. And the dx, like you can see here, the x-intercept is, this is 13, this is 39. So all of them are 13 and 39s, like you can see here. All of them are 13 and 39s. Very good, very good, very good. But how do I know which one's which? Where am I looking from? I'm looking from 0 to my 23, which is 0 to 200. 0 to 200. That is from 0 to 200. 0 to 200. 0 to 200. 0 to 200. So you are looking for the graph that's in the shaded area. Both the graphs have to be in the shaded area. So this one, the first one, both the graphs are not. The second one, yes. The third one, both the graphs are not. The fourth one, none of them is here. So the only graph that works for you is this. So that's another way to look at it. And again, you're trying to find the equilibrium between your consumer surplus and your producer surplus. And again, very simple, very important, but you have to make sure you understand. So please take your time to read, rewatch the videos, and make sure you understand this problem. And again, if you have any questions, simply screenshot and send it to me. Hope this helps.